Hi students, this is a video that is being brought to you by Dr. Ironman and Dr. D. Dr. Ironman is going to be narrating and Dr. D is going to be our videographer today. The goal of this video is to provide some reminders and pointers on the use of a compound microscope. First, let's quickly review the major parts of the microscope. Let's begin with the base, which is the bottom part of this microscope here, and the arm, which is connecting the base to the head of the microscope. Additionally, we have our light source, which is coming from down here at the bottom, but is controlled right here by this on-off switch. We have the stage, and this is where we're going to be placing our slide, and the stage clip right here that we can move with this lever for holding and positioning our slide. This also has adjustable knobs, which are down here, for moving the stage forward and backward relative to the light, as well as left to right. Okay, so beneath the stage, we have the substage condenser, which is this element of the microscope right here. It has its own knob that allows you to move the substage condenser up and down. And the substage condenser, as the name suggests, is concentrating light or condensing light onto the specimen. Part of this is also the iris diaphragm, which is controlled by this lever right here. And this is functioning like the iris of your eye. And we're going to have you manipulate both of these elements of the scope when you're looking at your specimens in lab to fine-tune the image and make the best observations you can of your specimen. We then have our adjustment knobs for focus. The larger of the knobs is the Coarse Adjustment knob. You're going to use this when you're focusing either on the scanning objective, which I'll point out in just a moment, and sometimes possibly to tweak the low power objective view. Embedded within this is the smaller knob, which is our fine adjustment knob, and this is for precise focusing once you've done your coarse focusing on scanning or low power. Once you get to the high power objective or the oil immersion objective, you are only going to use the fine adjustment knob. The final pieces that we have here are our lenses. So we have our ocular lenses right here, or our eyepieces that you're going to be looking through. One of these is able to focus independently of the other, and we'll talk about optimizing your focus with this ocular adjustment lens in just a moment. Then we have our nose piece, which is this piece of the microscope right here, and it is holding our objective lenses. There are typically 4 lenses on a compound scope. Yours will only have 3. We start off with the one with the red ring. This objective is a 4x objective, also known as your scanning lens, and this is allowing you to get a wide view of your slide to be able to find your specimen and get a coarse focus on your specimen. You then move to your 10x or low power objective that you can tweak a little bit with the coarse adjustment knob and then further fine tune with your fine adjustment knob. This is again good for viewing a larger piece of your specimen. If you then want to hone in on a specific area, you would center that piece of your specimen and then move to the 40x objective or high power lens. You would then only use your fine adjustment knob for focus at that point. Other compound scopes then have a 4th objective, which is the oil immersion lens or 100x. Those are not currently on your scopes. These are the parts and pieces of your microscope. Make sure you're familiar with them, able to identify them, and understand the function of each of these pieces of your microscope. When carrying the microscope, you should always use 2 hands. Hold it in an upright position with one hand on its arm and the other supporting the base. Be mindful of the eyepiece and the stage as you remove the scope from shelves. And always be careful to not jostle it too much and to be careful as you set it down or place it anywhere within the lab bench or the shelf space. To begin use of the microscope, first load the slide in between, not under the stage clips. So you can open up the clip, place the slide, and have it nestled or cradled between those 2 clips. Note that the stage is all the way down and that our objective is on the scanning objective. I'm going to turn the light on And I am then going to use my stage adjustment knobs to center my specimen, which I can clearly see here on my slide, over that circle of light. I'm going to begin focusing with this lowest or scanning power objective lens in position and change to the higher power lens when necessary. I'm going to start by focusing with the coarse adjustment knob and then fine tune with the fine adjustment knob to perfect my focus. I'm slowly bringing the stage up as I focus, and my image will pop into view and into focus. And then I can adjust with the fine adjustment knob. Okay. We can then move to higher power objectives, which should remain in focus as we slide from one objective to the next. We want to be careful about the location of the slide relative to the objective to make sure that we don't accidentally scratch an objective with the slide. Therefore, we're going to use the coarse adjustment knob with the scanning and lower power lenses, and only use the fine adjustment knob with high power and oil immersion lenses. We should not be using the coarse adjustment knob with high power or oil immersion. Again, pay attention to how close the objective lens is to the slide. So as you switch between objectives, you should always be looking at the slide and the objective as you make that change. Once you have your image in focus, you can continue to fine-tune your view of your specimen. You can control the intensity of the light, you can move the substage condenser, and you can control the iris diaphragm. I'll talk more about those three in just a moment, but it's really important that you make those adjustments to get the best view of your specimen possible. Also, to dramatically improve your comfort and skill with a microscope, you should spend time adjusting the ocular lenses for your eyes. Imagine, if you will, getting into a car that you've never driven before. Maybe it's a parent's or a friend's car, and obviously the mirrors are not in the right place, the seat's not adjusted to the right place, and it's going to be really uncomfortable to drive that car. And in fact, you might not be able to see cars behind you or next to you based on where those mirrors are focused. So when you get into a car that's not yours, you're of course going to adjust it. You're going to move your seat. You're going to adjust your mirrors, or at least you should. So we should do the same thing with a microscope when we go to use it. We should make sure that these oculars are set for our eyes. Binocular microscopes and stereo microscopes have one ocular lens that is adjustable. This enables you to adjust the viewing for your eyes so that you don't need to wear your glasses, for example. First, you're going to find your specimen under scanning power and adjust the focus with the coarse knob. Then you're going to adjust the interpupillary distance until it is correct for you. This is the distance between the pupils of your eyes, or in this case you could think of it as just your eyes themselves. And so you're going to be able to move these back and forth. You'll look through it and you'll adjust them until you have a single circular field of view. If you have two distinct circles or even two overlapping circles, this is not set correctly. Again, you should see a single circular field with both eyes open. We recommend that you write down this distance, as there's a measurement here on your scope. Write that down so that when you use a different scope or even the same scope in the future, you know where to start, at least, to have the best chance of having the correct interpupillary distance. Now we're going to go ahead and make sure that we have our 10x objective in place. And we're going to cover the adjustable lens, which is the left lens, with our hand, or close our eye, or somehow prevent our view through that ocular. Looking just through the right ocular then with our right eye, we're going to fine tune our focus using our fine adjustment knob. Once that focus is fine tuned for that right eye, we're then going to close the right eye and come up to the ocular lens and turn this ocular focus on the left lens until it is set for our left eye. Now we should have the focus independently set for each eye so that we have the best view of the image possible. This is going to prevent things like headaches. This is going to make it more comfortable to use the microscope for a lengthy period of time, and it's going to allow you to use the microscope without using your glasses. You can then continue on adjusting the image so that it's sharp as you move to perhaps the 40x or high power objective. Again, to make the best observations using a microscope, you need to continue to adjust the lighting of the scope. During your practice, be sure to adjust the light intensity, the condenser lens, and the iris diaphragm. The light intensity changes the brightness of the light. The condenser lens collects and directs the light. And the iris diaphragm works like the iris of your eyes. What happens to your image as you adjust each of these settings? Let me remind you that the brightest light is not necessarily the best light. You want to make sure the light intensity is appropriate for the image that you're looking at, as well as for the comfort of your own eyes. You're going to want to move that condenser to determine how focused you want that light to be on that very specific part of your specimen, and you're going to want to move that diaphragm. Play with it, you'll see why. And you'll want to adjust these each time with different specimens to get the appropriate amount of light coming through the specimen that you are currently observing. Compound microscopes are an invaluable tool for making observations of specimens. However, like all tools, they depend upon the skill of the person using it. Be sure to practice making these adjustments so that you become an expert with the microscope.